In previous lessons, we've talked about games that put things in order. In this lesson, we'll look at the second major task, putting things into groups. Let's look at a game together. Here's the setup. Each of exactly 5 persons, Nguyen, Olsen, Pike, Tyner, and Valdez, participates in exactly one of 3 activities: going to a movie, going to a soccer game, or going to a restaurant. This is a group game because the clues state that more than one element can be placed in each slot. It is fixed assignments because the setup states that each person participates in exactly one of 3 activities. However, nothing in the description requires at least one person participate in each activity. So at this point, it's possible that one or more of the activities will have no one assigned to it. Now, make a diagram using the activities M, S, and R as the core. The inventory is the list of people participating in these activities: N, O, P, T, and V. Next, it's time to symbolize and double-check the clues. The first clue states that N and O do not participate in the same activity as each other, nor does either one of them participate in the same activity as P. This is actually 3 clues in one. N cannot be with O, N cannot be with P, and O cannot be with P. Use anti-blocks to symbolize these clues. Clue 2 states that exactly 2 persons go to a soccer game, so put 2 slots in S. Clue 3 says that Tyner and Pike do not participate in the same activities as each other. This is another anti-block with T and P. Clue 4 states that if N or V goes to a movie, they both go to a movie. Symbolize this as 2 separate conditional statements. If N goes to a movie, then V goes to a movie, and if V goes to a movie, then N goes to a movie. Be sure to immediately take the contrapositives of both statements. So, if V doesn't go to a movie, neither does N, and vice versa. Now, after carefully double-checking the symbols, it's time to look for deductions. There seems to be a lot going on with N, O, and P. Since N can't be with O or P, and O and P can't be with each other, that means that N, O, and P must be in 3 separate groups. So, create a placeholder for one of these elements in each slot in the diagram, and now you know that there is, in fact, at least one person assigned to each activity. Now it's time to do some counting. When a group game doesn't tell you how many elements can go in each slot, be sure to determine the possible distributions before you begin playing the game. This will make questions go much faster. You already know that N, O, and P are divided up with 1 in each activity. That leaves you with 2 elements to play with. However, 2 and only 2 people must go to the soccer game. That leaves 1 person left over to either go to a movie or to the restaurant. So, along with the 2 watching soccer, there is either 1 at the movie and 2 at the restaurant, or 2 at the movie and 1 at the restaurant. Also, what is your most restricted element? Poor Pike. No one except V is willing to hang out with Pike, so P is either by himself or in a group of 2 with V. That's it for deductions. Now it's time to work through the questions. Start with question 1. It's a grabber rule. You know that N, O, and P have to do different activities, so that eliminates choice A. 2 people only go to the soccer game, so that eliminates choice E. T and P can't participate in the same activity, so that eliminates choice B. And if N goes to a movie, then V goes to a movie, and vice versa, so that gets rid of choice C. You're left with choice D as the credited response. Now let's try question number 2, a specific question. If V goes to a soccer game, each of the following could be true except. Remember, could be true except means to look for what must be false. The next step is to start a new line and assign V to the soccer game. Now, fill in your NOP placeholders. That means that the second person watching soccer is only allowed to be N, O, or P, and there's no room for T. Since it's a must-be-false question, now's a good time to take a look at your answer choices. And choice D says, Tyner goes to a soccer game. That's it. There's your correct answer, and you're moving on to question number 5, the next specific question. Question 5 asks, if N goes to a soccer game, Then which one of the following is a complete and accurate list of the persons, any one of whom could go to a movie? We're looking for a complete and accurate list of the people who could see the movie if N goes to the soccer game. Start a new line and plug N into one of those 2 soccer slots. What else can you deduce? Well, according to clue 4, now V can't see the movie since N doesn't. That eliminates choices B and D. Your answer to the grabber rule establishes that P could see the movie if N watches soccer, so the credited response must include P. This eliminates choices A and C, and you're done. You've eliminated down to choice E, O, P, and T. You're out of specific questions. It's time for the 2 general questions, 3 and 4. Question 3 asks, which one of the following is a pair of persons who could go to a movie together? First, use the clues and deductions to eliminate what you can. You know from clue 1 that no 2 of the trio of N, O, and P can ever be together. That eliminates choice D. Clue 3 says Tyner and Pike can't go together, which eliminates choice E. Clue 4 says that either both N and V go to the movie, or neither does. You also deduce that either 1 or 2 people go to the movie from the possible distributions. Well, for choice A, if N and T go, V would have to go too, but that's too many people. Same problem for choice C, which has O and V. N would have to tag along, and that makes 3. That leaves you with B as the credited response. Question 4 says each of the following must be false except, so you're looking for the one that could be true. Since you haven't had to do much work for the other questions, the only previous arrangement you have to work with is your answer to question 1. So let's dive into the choices. Choice A says only O goes to a restaurant. Question 1 choice D doesn't help on this one, so test it. If O will be enjoying the restaurant by himself, that means 2 people go to the movie and 2 watch soccer. Well, that means that P and V must be together since now P can't be all alone, which also forces N and T together. But this presents a problem. If P and V watch the movie without N, it violates clue 4. And if P and V watch soccer, putting N and T in the movie, it also violates clue 4. That means choice A must be false, and it's out. On to choice B. Only P goes to a restaurant. Promising, given P's unpopularity, but let's test it. If P is alone in the restaurant, let's put N and V in the movie since they work well there together. That puts T and O watching soccer. No rules have been broken, meaning B is your correct answer. Finally, it's time to attack question 6, the complex question. If the condition that exactly 2 persons go to a soccer game is changed to require that exactly 3 persons go to a soccer game, but all other conditions remain the same, then which one of the following persons must participate in an activity other than going to a soccer game? Now, 3 people go to the soccer game, and it's time to reevaluate the deductions. The anti-blacks haven't changed, so it's still true that N, O, and P have to be in different groups. It's also still true that P can only be alone or with V. That should make you pause and think, can P go to the soccer game with 2 other people? No. Since the question is asking who can't attend the game, and P appears in choice C, that's all you need to pick choice C.